Oh, cool, Sam. Probably. Bear in mind, Sam, your screen's up, so you may want to just take that off. Or
Is
go
it
to the
still?
yeah.
Such a pain in the ass. How do I unshare? Oh, stop share.
Yeah,
Okay.
the stop button helps. Hello, everybody. Welcome to our webinar on open source model validation testing. We'll just wait for a number of people to join because it's before the hour. Very excited to be presenting this work, and I've got two of the actual people who've really been the stars of the show on this with us today, Sam and Pete. It's very lucky to have them. But yeah, we'll just be waiting till about 1 minute past, and then we'll try to get underway, and hopefully give everybody some insight into model governance and testing, generally speaking. It's a popular webinar, this one. I've never had people join before the allotted time. So very good to see so many people coming through. Awesome. Welcome to those people just joining us at the moment. Just waiting a couple of minutes for everybody to join on their lunch break. Is that a guitar in your background, Sam? No, it's a tie-dye shirt or something like that.
Where is it?
I think on the right-hand side of the screen. I'll just embarrass you casually whilst we wait.
So. Yeah, no, that's great. No guitar. I wish.
Everyone will note the American accent. With this, unfortunately, this business is increasingly becoming Americanized. So we're very lucky to have a number of our teams joining from various different places in the world, and as we really start to build out a very, very global team, it feels very, very surreal at times. Pete and I were just joking about the days when we actually used to do things as opposed to, pretending these days and having much smarter people around us. All right, look, we might kick off from here. As I said, thank you so much, everybody, for joining and for joining today. I'm probably just going to set a bit of context on this presentation and why we feel it's so important. I'm going to hand over to Sam to really walk us through everything that's kind of happening in the space, how to apply the model governance framework and things like that. So just to set some context on the call, you've got Sam. He's one of our senior data scientists, based originally from the States, now in Sydney. You've got Pete, who is our head of data science and product, and obviously myself, Henry, or Hen, who's the CEO and co-founder of the business. We in the last kind of 2 weeks, we launched an open source governance framework for market mix models to try to evaluate market mix models in a comparable fashion, particularly when there are so many different methodologies kind of proliferating around, both from open source and from third-party vendors. To give a sense of why we think this is important, I think it's important to start at where our company vision is. We feel that from a first principles perspective, market mix modeling and market mix modeling platforms are not a real product. Nobody wakes up in the morning and goes, I want to buy a market mix model. That is just the tough truth of the sector. What people are looking to buy is actually a higher order and more important aspect of it, which is answers. And answers need to cut into three things. They need to be granular. They need to be highly timely and responsive. And they also need to be trusted. And so one of the things that we've seen across the market is that there's a huge variance in how models are governed. And in particular, there's not much transparency into how third-party models are governed versus open source models. Our attempt here is to try to create a governance standard for market mix models to be held to account to. One of the things that I think that's relatively important here is that market mix models are increasingly going to shift to answers products, which means there's going to be a wider and wider range of people consuming these answers. And so if these answers are not well trusted, that's certainly going to be highly problematic in our opinion. Just to show everybody what I mean, like this is exactly the type of interface that we would expect to start to dominate the MMM space. So, if I click here, analyze November 2023, what are the changes that I made over time? And this is obviously a fake instance, but you're actually able to get that answer really, really quickly. Part of the corresponding effect of this is to be able to actually have a very clear understanding of where the error terms are, what the accuracy of the model is, and so on. So this is a good example of where these sorts of metrics can start to come through here. As you see, uncertainty in a model. And then under the hood, we have a whole heap of governance metrics which must pass in order for us to make decisions off that model. Why is that important? Because long-term, we believe that as you're delivering more and more answers through the MMM framework, increasingly, without those answers being verified and validated and governed properly, we're going to see more and more misfires of the MMM product and sector generally. I will note that we don't think that many of the open source models perform well out of the box. So that's a critical component to this work, is trying to give people an evaluation framework to understand when and when not to use an open source model, or when and when not to use a third-party vendor and model. We also have a strong belief that this type of governance should be radically transparent and open source. Why? A vendor who's not willing to verify publicly and transparently is probably lying to you. And so we have a pretty strong view on that. I think as the leaders of the market mix modeling sector, we have a responsibility to drive the governance standards from an ethical perspective, more so than anything. I'm going to hand over to Sam now, who's going to run through exactly the framework, how it works, give a bit of a demo of how to apply it, and how it all comes together. Over to you, Sam.
Thanks, Henry. So before I get into the nitty-gritty details of the library and how it works, I first want to back up a little bit and just talk about why validation of MMMs is challenging in the first place. So most people use MMMs. What they are looking to get out of it is an evaluation of how well their various media channels are working, right? So that's things like high ROI, low ROI, which channels fall into these different categories, which are maybe overinvested, underinvested, right? So ideally, what we would do is we would test for that explicitly. We say which model predicts ROI the best. But there's a problem there. It's very hard to get an actual ground truth measure of that. The reason for that is what you would need to do in order to measure that is you would need to hold every other sales driver. That includes other marketing channels, as well as things like pricing, promotions, seasonality. You need to hold that all constant, and you would just change, say you're interested in TV spend, you would just need to double your TV spend. Does the uplift in sales match what's predicted by the model or not? That's a great world if we actually lived in it, but in practice, that doesn't actually work. And it also ignores things like channel synergies and halo effects that are very important to consider. So our philosophy on testing is that because we can't exactly measure what we want, what we can do is provide a suite of diagnostic tests that uncover a lot of common model issues we've seen with MMM. And given that we've been developing MMMs for several years now, we've seen a lot of these potential pitfalls, and we just want to create tests that will flag those. So when I say diagnostic tests, what do I mean by that? I'll just give a sort of silly analogy here. Say you go to your doctor and you say, "Hey, I'm having these symptoms. I'm a little bit worried that I have some scary disease. Can you run a test for that?" So unfortunately, in medicine, there's generally not one test that a doctor runs that says with 100% certainty, no, you don't have that disease. What they will do is they'll run a suite of diagnostic tests. If all those tests come back negative here in this example being a good result, you have a lot of confidence that you don't have the disease, you don't have that certainty, but you're much, much more confident than you were before. However, if some of those come back positive, again, in this example, positive is bad, that's a red flag, and you probably need to be a bit more concerned. It's the same thing here with MMM, and that's what we attempt to do with these tests. The other benefit is that we sort of design the test to, based on which ones fail and some patterns that emerge, we can usually determine what's actually wrong with the model and ideally improve the model so it's better in the future. So that's sort of the overall framing. Hopefully that makes sense. Let me hop over to screen share quickly and just show how this can integrate into your workflow. All right, can people see my screen? I think that's working. Yeah. Okay, so I want to first acknowledge that there is code here, and because I don't want people to leave the webinar in protest, I promise I will not step through it line by line because I know that's how to bore people to tears. I'm just going to sort of use it as a jumping off point to explain the different tests and just show an example of literally how this can be integrated for people who are using open source MMMs. The other thing to mention here is that our framework, the way it's set up, it currently supports two open source MMMs. The first is Google's Meridian. That's the one I will be demoing through today. The other is PyMC Marketing or PyMC Labs, PyMC Marketing, MMM. The way the framework is designed, though, it should be really easy to integrate other open source MMMs. There's details on that in our developer documentation, and we're hoping to, expand the number of models that are connected here. It's also agnostic to the type of the model. So regardless of whether it's a Bayesian model, as many MMMs are, or a frequentist model, all the tests are still valid. They can still be used for evaluation. So jumping into this notebook, I'm going to just ignore all of this code here and say, if you're using Meridian, you would be writing this code anyway. This is defining a model, defining some configuration, setting priors, all the things that you would do normally. This has nothing to do with our package, right? So now you have your model. Maybe you have multiple different models, some different configurations, but you don't know which one is best. You might look at the results, you might look at ROIs, but at the end of the day, which model is the best? It's really hard to say. What you can then do is connect up to our package by, I won't explain the exact steps, but it's very straightforward. Everything in these two cells here, so like 10 odd lines of code, is all you need to connect up, and then you can literally start running the actual tests. So this is meant to be very low touch, should integrate into existing workflows, shouldn't be a pain to use at all. So let me talk through the actual tests that we have implemented. So and actually before I get into that, let me just explain what we're showing here. So these are results for each test individually. There are 6 different tests, and they each measure something a little bit different. This is for one single model. In practice, what people will likely be doing is testing multiple model configurations against one another, whether that be different Meridian configurations or comparing Meridian versus PyMC or whatever open source frameworks we're using, right? So these are just one test at a time to sort of show, okay, what's actually coming out of these tests, what are the results, and how do I interpret them? Another thing is this is using Meridian, can be a bit memory intensive, so it helped to just run them one at a time. So there's 2 like broad categories of tests that I'll talk about that we've implemented. The first is accuracy. So that sounds very generic. What's meant by accuracy in this context? In the context of MMM, so MMM is a regression model, right? You're trying to predict sales using a bunch of different input factors, whether that's revenue or volume. It depends on your use case, but ultimately you're trying to predict sales. If your model cannot predict sales accurately to within like a reasonable degree of precision, then it's not a good model, right? There's no way you're going to get valuable media insights if you can't even predict the target, right? You're not controlling for other variables properly. So that's kind of where we start. It's just like a reasonable thing to check first. So the first test we have here is in-sample accuracy, kind of the simplest of the bunch. All this is saying is I have a data set, I train on that data set, I make predictions on that data set. How close are my predictions to the actual sales trend over time? So again, this is sort of the lowest bar for a model to hit. The metrics that are reported here are pretty straightforward industry standard. We have MAPE, which is mean absolute percentage error. Just think of it as average percentage error over time. R squared is another common metric, goodness of fit metric for regression models. I should say here we're using synthetic data, and we didn't fully train the model, so these values are not very good. That's expected. This is just like for demonstration purposes. The other thing to mention, which I think is important, is we have this metric pass field. So what that means is in the library, we basically have a bunch of different thresholds defined for each test. And we have sort of default values in there that we think are reasonable. But if you were to use the library and you had some internal metrics you want to set, you want to say, hey, we're only going to go to production with models that have a MAPE under 15%, for example. You can set those thresholds, and then you can get this nice sort of binary outcome, like, did I pass the threshold or did I fail? So yeah.
And Sam, just to jump in here, why should you care about those thresholds? Well, let me just explain just very quickly for in-sample. If you've got an in-sample MAPE that's wildly off, the model is terrible at predicting anything that happened that it's seen. So it's almost like if you're walking, if you kind of think of a model walking down, it's a person walking down a street, they walk down a street with a bunch of trees, and said, oh no, I walked past a bunch of buildings, not trees. That's how you'd interpret that model. Why is that important? We don't want models in MMMs, and this can happen so frequently. Like, I cannot tell you how often we see bad models that have good looking ROIs for marketers, but have no utility whatsoever for financial planning or forecasting. None. Like, they should never have gone near the CFO. And so by having these pass-fail metrics, we're doing one of two things. One, we're saying that the model automatically is credible. But two, we're also flagging if it's not, and if there's something that we think as Mutinex, but you could change this according to whatever you wanted. That's why it's open source. But if there's something that we think that would trigger what I like to call the oh shit metric, that's what these basically are. So when you see false on these evaluation tests, and you should be running every one of these evaluation tests on your models. If you want, and you're going to a CFO asking for money, you're crazy. It's very, very, like challenging to basically use these models in a financial context. So I would call that the oh shit metric. If you see false there, it should be the oh shit metric. Marielle, just to answer your questions very quickly, yes, they have offered in-sample MAPE. The out of sample MAPEs do not have long thresholds. Meridian explicitly makes that quite difficult. We'll move to out of sample shortly as kind of one of the key metrics. I think the critical part here is having the same evaluation metric across multiple models, because the methodology in which in-sample MAPE is calculated on one may be different to another. One of the things we want to do is have apples for apples comparisons. And so an evaluation framework should be running in the exact same way across all models, including PyMC and your third-party vendor, and immediately. So what that allows you to do is go, are we better with Robin? Are we better with Meridian? Are we better with PyMC? Whatever it is, you can be running this and getting those metric pass fails in the one system. From an evaluation perspective, we think that's a lot more important than say, as much as I love pitching a shiny deck as much as the next person, I don't think that's very helpful. Yes, that is correct, Mario.
Great. Thanks, Henry. Yeah, very, very useful context. So moving along, I think you already sort of alluded to this. The next test we have here is holdout accuracy. So what does that actually mean? In simple terms, it means you've trained a model. Now, how well does it perform on data it hasn't seen before? When the model's been able to fit to data it's seen, it's pretty unsurprising that it'll predict pretty well. But on unseen data, it might not. And that's a very important metric to consider. So the way this actually works in practice is we have a time series data set. We pick a date towards the end of that data set. We split the data. Everything before that date is training data. We train the model on it. Everything after that is test or holdout data. And that's what we make the predictions on. And this is especially critical, again, because if you are forecasting using this model, if you're, allocating marketing budget based on this model, it needs to be able to make predictions on data it hasn't seen yet. Otherwise, it's essentially worthless. Yeah, we'll just flag again, this is an especially critical metric. We've heard from some of our customers who have, previous to working with us, worked with solo practitioners using open source models who've reported, out of sample MAPEs of 50% or more, at which point, you really can't trust any marketing insights that are coming from a model like that. So really, really critical one to check. Next test is cross-validation.
So sorry, Sam, just give everyone the worked example of this just very quickly.
Yep.
This would be as if the model was going to predict, next month you were going to get 50 million sales, but actually, what the model typically would get if we were testing those predictions properly, it might actually show you that actually the model was more often getting 25 million. Why that's important is MMMs are meant to be tools that drive credibility in the boardroom. And if the MMM is consistently steering you 50% wrong, the MMM is consistently steering you 100% out of credibility in the boardroom. And so I think that's just a really critical point. Meridian and other frameworks do not like this particular metric. And the reason why is because it requires quite deep business context to get this metric right. And it requires quite strong model governance practices to get this right, which may mean that you need to put things like pricing variables into the models. Now, that's not a stock standard thing in open source. It is in PyMC, but I think that's a really, really important aspect to this. There are kind of more bespoke iterations of the open source models that I have seen that do really, really good jobs of hitting that metric. But if you were to kind of say to anybody in a boardroom that my metric was 50%, my forecast was 50% off, you'd kind of get laughed out. That's what we want to test these models for. We want to actually test that those predictions are really robust and accurate. Barry's son asked, what level of MAPE would you consider as being reliable and passes the test? We would say above 15% is huge red flags for us and triggers a heavy governance review. We would typically expect it to be sitting between 6 to 8% with some degree of variance, assuming that stability tests are passing. So I think that it's important to consider those as a suite of tests together because they do inform different aspects of the reliability of it. And that's on out of sample, Barry, to be clear.
Yeah, agreed on all that. So natural segue, really. The next test is cross-validation. So this is actually very similar in spirit to the hold out accuracy test. All it means is that the procedure I talked about, splitting the data, training on the before, validating on the after, we do that multiple times. So we split the data, train, and evaluate multiple times, and then average the results over that period. So by doing that multiple times, maybe in the last 2 months of your data, the sales signal was just really, really easy to predict, but for the rest of the series, that's not the case. With cross-validation, sort of doing a more robust check on the model's ability to do that. So another important test to consider. So you'll notice here the metrics we're looking at, it's mean MAPE, because we're looking at MAPE across these different splits, different evaluations. All right, moving on to the remainder of the tests. These can be broadly categorized as stability or robustness tests. So what does that mean? It means that as you add more data to the model, or as the underlying data you have maybe changes slightly, what happens to your model when you refit on that data? Does it go absolutely haywire? Do the ROI estimates change drastically per channel? If so, that's not a good sign. That's the sign of a brittle and an unstable model, and not one that you can really trust. So these tests aim to basically address that through a few different lenses, which I'll go through. So the first test we have here is refresh stability. Guessing many people on the call will be familiar with what refresh means in an MMM context, but it just means that you fit an initial model and you observe more data, another month of data, another quarter of data, and you sort of want to update your model to accommodate that additional data. Now, a model that changes a little bit when it's given new data, that's actually expected. If the model is not learning from the new data, that's not a great sign either. However, if you see these radical changes, a small change in the input causing this huge change in the outputs, that's really cause for concern. So we're basically just simulating that refresh process, adding more data to the model, retraining, and then what we report here are the percentage changes in each media channel over those different simulated refreshes. So hopefully that's not too confusing, but the overall intuition here is, well, you want these numbers to be, yeah, they'll be above zero, like almost certainly, but something like this, and again, this is just simulated number, or trained on simulated data. So this number is really high, but if you had an average change of 400% in your ROI when you're refreshing, that's a massive red flag.
Sorry,
All right.
I'll just jump in very quickly on that one. So refresh simulation might seem like a relatively trivial kind of test, but it's one of the key ones that we believe should be used by businesses for trying to build credibility with the model within the organization. Like, to go back to kind of Henry's points around presenting to the boardroom or presenting to senior leaders, right? If you run a model and you say, oh, our aggregate marketing ROI is 40%, and then you add another month of data in and you go do it again, and suddenly you're getting 80%. Like, you can't really take that to the board and say, well, we've doubled in our marketing ROI in an entire month. Like, it's probably not going to be in the realms of plausibility, and it's very hard for you to kind of make decisions when your kind of baseline or your reference point is changing that substantially. So it's a very key piece of the puzzle for helping not just building a good model, but building credibility and trust within the model within an organization. So it's one that we really believe in. And again, like, these tests should not be done in isolation. It should be done in conjunction with all the others. So we don't believe it's enough on its own. But yeah, it's definitely a key one. Now, Sam, just before we jump on to the next test, there's just a couple of questions that have popped up. So I'll throw back to you to answer. But what period and volume of training data would you require as a minimum or ideal? This was in reference to the outer sample kind of testing that we were talking about before.
Yeah, it's a fair question. It depends a little bit on the granularity of the data, but a very common granularity that you'll find is weekly. So just for context, our defaults in the package, and this is aligned broadly with what we do at Mutinex, is we require at least 2 years of data for training an MMM. That's pretty important for making sure you're getting seasonal factors, for example, the model correct. And then in terms of how much of the data to hold out, rather than look at like a percentage necessarily, I think somewhere between 1 to 3 months, anywhere in that range is a pretty solid place to start.
Awesome. And then I'll take this last question from Jack. So why is overfitting the model bad, and how does it relate to stability? So I'll give you just an example for this one, Jack, but like, pretend you're an e-commerce business, right? You're all online, you do a lot of digital kind of marketing, but you also might have some out-of-home kind of work. If someone is going to go and buy something from you, they're likely going to Google your name, the name of your brand, and then click on your website, and then suddenly that's search spend right there. And then you have all your customers starting to use search as kind of the way of navigating to your store in the first place, and you have like a signal that is now very, very collinear with your sales target. So in that situation, you're probably likely to have a model that has very, very good predictive accuracy if you just say 100% of my sales comes from search, because everyone who is going to your website is going via Google or going via a search engine. In that case, you're not actually measuring your actual real world marketing ROIs. You're not looking at the synergy between all your different channels, and you've got a model that is overfit. And then would be very, very sensitive to changes in that search spend. So what you would then have is, like, say you turn search off or you increase search, and suddenly your ROIs go up. And it's potentially it's potentially stable depending on what you're doing with your search, but then it's potentially unstable. But irrespective of kind of how you measure stability in that case, you don't want that code linearity there that kind of results in overfitting of a model. So you need to kind of be very careful when you do these tests that you're decoupling for that. And we kind of see, we get to that a little bit more with some of these other tests here around perturbations and placebo, where we try and correct for some of those issues or detect instances of code linearity.
You can think of an overfit. It's a little bit like, if I'm commuting every day and, and I walk through that ticket barrier every day, it's very easy to say that the reason I commute every day is because I tap my phone on the ticket barrier. No, I tap my phone on the ticket barrier because I need to commute every day. So it's very linked to this concept of, it's very easy sometimes, because sometimes sales can cause media spend and not the other way around, or seasonality can cause media spend. So and I'll give you a really good example of this, just like on retargeting. So if I'm doing lots and lots of advertising to people and driving lots and lots of people to kind of product pages, I'll naturally have an increase in my retargeting spend because there's just more people to retarget, right? And I'll see a surge of that. My search will go up. My sales will also go up because I've driven a whole bunch of people to those pages as well. So in practice, we want to, it's very hard for me to kind of say, let's build a test to kind of find, that specific overfit. But it's very easy, as Sam said at the start of this call, it was like, okay, sometimes we can't give a test that gives us the exact diagnostic because there's not one test that'll find it, but we can put a series of tests around it that we know that if none of these trip up, then definitely that thing doesn't exist. So you can think about testing for stability, if you're kind of trying to understand what's changing, if you slightly change the channel, what happens, all of those sorts of things, allows us to test if there's a really sensitive overfit. Testing placebo variables is a similar thing. And so what we're really trying to test here is do we see any signals of it? Because in media and marketing, that overfit is super, super common just by the nature of how marketing works.
Yeah, and the last point I'll kind of make on this before we let Sam move on is that the key piece that you're trying to solve for and the key piece you're trying to avoid with overfitting models is you want causation in your MMM. You don't want correlation. Now there's a pretty semi-famous or popular kind of analogy around this, where there is a strong correlation between the number of drowning deaths in the US and films that Nicolas Cage has appeared in. Now I'm not here saying that Nicolas Cage being in movies is resulting in drowning deaths, and you don't want your model to kind of be learning those kind of patterns as well. So it's very kind of key that we solve for that. All right, Sam, back to you.
Yeah, thanks. Okay, only 2 more tests to get through. Hopefully people are not drowning in the technical details, but yeah, the context from Henry and Peter is super helpful. Second to last test here we have is perturbation. It's really just a fancy name for what we do is we train the model, then we take the media spends that go into the model, we add a little bit of noise to them, just tweak them a little bit, we retrain the model, and then we look at the ROIs that come out of the difference between those 2 models, the deltas. And again, if those deltas are really high, that's a red flag. If they're relatively small, yeah, we change the input, we expect the output to change. But an order of magnitude difference in that level of input versus output, definitely a sign of a unstable model. So again, here what you're looking at is percentage change in ROI from adding on the order of 5 to 10% noise. And again, we think this is a reasonable test because, while we may not like to admit it, data in the real world is dirty. It's not always perfect. There can be inconsistencies, but a good model should be robust to that and should be able to handle that without seriously sacrificing performance. Last test we call placebo or falsifiability test. Essentially what this is a good model, if you give it a nonsense feature, it should correctly recognize that it's a nonsense feature. That's the idea. So what we actually do in practice is we take one of the media spend channels over time, we shuffle that in time. We just sort of like randomly permute it, essentially. Then we feed that into the model. At this point, that feature is worth nothing. The correlation with sales is completely off. A good model should recognize that that is not a good feature, and it should assign it a very, very low ROI in that case. Maybe not exactly, no ROI, but closer to zero return.
So if you know that old term, garbage in, garbage out, what we're trying to do is throw some garbage in, and actually knowing that the model should be smart enough to go, that's garbage, go away, and if it doesn't go, that's garbage, goes away, and goes, oh no, that's not garbage, that's gold. We know the model's full of shit, and so that's like the simple way to explain this one. And so again, why this is particularly important is like, this is a classic causal inference mechanism. So a strong causally sound model will not react to nonsense variables. A really weak causally sound model will overreact to this kind of variable. And so this allows us to really kind of diagnose and dig deep into that, because it actually kind of stops that. Now, within the Mutinex world, we need to see all of these kind of passing for us to know that actually this is a model that's credible to be used in financial terms to make millions of dollars in decision making. Because you can just think about it really simply. Sorry, Stan, I am stealing thunder a little bit here, but you can think about this really simply. If I was to say to you in any situation, hey, I added 0.02% of spend to one channel and it wildly changed my ROIs, you think, oh, that's not a very good model. If I was to say to you, hey, I'm going to use this model's forecast, but I know it's going to be 50% off, you think, oh, that's a very good model. And if I was to say to you, oh, I'm going to throw this new variable into the model that I know doesn't really matter or do anything, but I'm just throwing it in because the boss told me to, and it stuffs everything up, you go, oh, well, that's not a very good model. And so the whole point of this is to actually create a set of governance standards to protect against these things at a much wider range and at an industry level, because actually the kind of critical factor that's going to dictate whether or not MMMs become well adopted and move beyond models with an army of consultants around them, which, let's be honest, nobody wants an army of consultants around bloody anything. And instead kind of moves towards being standardized infrastructure. Any standardized infrastructure, like if you jump on a plane, it's gone through all these safety tests and standards that make you confident that flying in that little tin can in the sky is going to be fine. The same thing needs to happen if we are to get the mass market of adoption moving from deterministic models, which are now impossible to operate under the new privacy regulations and under the Privacy Act changes, to probabilistic models where they need strong governance and strong governance practices to make them operate well and at scale. So by championing that change, by having this kind of out there, what we are trying to do is, A, set that governance standard. I will say that we've been stuffed on these governance standards 2 or 3 times, by the way. We have not had an easy run imposing these on ourselves. They have created some extremely uncomfortable conversations for me over the past 2 to 3 years, and for Pete as well. So, but I think that, governance isn't governance if it's green all the time. Governance is only governance if it holds us to account for driving strong standards, strong model quality standards across the market. The fact that I have in RFPs only seen model governance maybe 1 in 5 times in a market mix model astounds me, because I think if I was assessing a vendor, I couldn't give 2 shits about how good their user interface is and things like that until I was confident in the testing that they were delivering to make that data reliable to use in that interface. And so I think that's a critically important factor here. We want to move away as an industry from jazz hands. We want to move towards good governance, good practices, evaluated across multiple models. And also, frankly, you should run the open source models against your third-party vendors. If your third-party vendor is not willing to actually have an open source model run against them, I mean, what are they afraid of? honestly. We should be welcoming that kind of scrutiny, welcoming competing for the best models, welcoming actually trying to deliver a robust industry that is the best in the world for financial forecasting. If we're not committed to that, I don't know what the point of being in this business is. Founder rant over.
Well said. That's it for the test. I just want to point out one more thing about this test. So the convention we use for ROI, it can differ between different frameworks, different organizations. The way we have it set up is that -100 ROI means that however much you spent, you got no return. So for a good model, you would hope that this value is close to -100. It may not quite get there, but if it's close to -100, then the model is correctly identifying, yes, this is actually a garbage feature. That's it for the tests. The last thing I want to briefly touch on, I don't know if there's any data scientists or analysts or developers on the call, but I just want to briefly show the layout of the repository. If you have any questions on how to use it, you can just click over to the documentation that's linked right in the page. It's searchable, should have all the information you need. If you run into any issues, you think you've uncovered any bugs, you can raise an issue here. If you want to start a discussion thread on anything such as, why do we implement this test this way, or should we add this test, or anything like that, feel free to drop it in there. We encourage submissions of code as well. So if you want to open a pull request, you want to submit some code, we're more than happy to take that into account. We want this to be, we recognize that this is a starting point, and we're excited to, develop it with the community, with everyone's input. That's all I got. Henry, anything else, or should we go to Q&A?
Guys, we'll now take questions from anybody. So if you have any burning questions or you want us to cover anything, please ask away. Give it 10 seconds. No questions. Gosh, tough crowd.
We just did that good of a job, man, explaining it. Oh, there we go.
Might put that to you and Sam and yourself, Pete.
Yeah, sure. The p-value, I mean, it's a bit of a vague question, I think, Barry. So like the p-value usually just kind of gives you an explanation of like how confident you are in a particular result when you're looking at certain metrics. So it also tends to be, like a metric used in frequentist approaches. So by itself, there is no p-value in this kind of metric, in this kind of package. But if there's a particular test that you think is worthwhile or including in the model, let us know, and we're very in the package, we're very happy to kind of explore it.
We do have R² for the MAPE test, which is more in that realm, but definitely happy to entertain any other metrics that people would find useful.
Is there a minimum amount of spend and revenue needed for MMM models to work?
Yeah, I'll take this one. So spend and revenue, it's probably like how workable is the technique? Like what's the ROI payback? I think you need two things. One, you need at least 2 years, preferably 3 years of weekly time series data to make this work. I think the second thing is you need variation. So one of the things that, if you're just spending on one channel and you've got the same sales every single week, the MMM is pretty useless. Our general guide to this is if you're spending 3 million in revenue, 3 million media spend, generally the cost of implementing a market mix model will be somewhere in the range of 100 to 300 grand. And so we believe that it's roughly like pays itself back in spades above that 3 million threshold. Below that, we have seen that the business case can be challenging. And so we generally just try to avoid in that particular context, avoid sorting it out, avoid kind of, bringing that through.
Yeah, so I think that actually leads into kind of Jack's question quite well around how much human intervention and decision-making is included in setting up the model. That could differ between vendors. Could those initial decisions have long-term implications? So The short answer is yes. Those initial decisions and kind of how you set priors and how you configure models have massive implications. And this is one of the things that we try and hope to catch with this kind of open source package a little bit as well, is that we believe that those initial assumptions that you embed in the model, those priors that you set in kind of under Bayesian frameworks, if they are biased and you use bad data or finger in the air kind of approaches at setting that, or there's some senior leader who is pretty certain that TV has always had a 200% ROI because they've kind of bet the house on that a little bit in terms of their marketing budgets. If you put those into the model and you bias the model, you should be ending up with very unstable models and models that are not predictive, because you're forcing the model to tell a particular narrative. And this is one of the issues with MMM in general, is that it is relatively easy to force the model to tell a particular story with very biased priors. So, and not to try and advocate for Mutinex too much, I want this to be objective, but it's one of the reasons why open source packages and kind of the consultative approach to MMM doesn't really work, because you've got small data sets and you're trying to train models that need to be robust and need to be objective and not biased. And with the small data sets, you don't have the ability. So having a large wealth of data across multiple customers to kind of learn these dynamics and learn how channels perform and learn how ad subs perform over time gives you the ability to set priors that are based on data and not based on bias or gut instinct.
Or bullshit.
Or bullshit, yeah.
Well, look, everybody, we really thank you very much for your time. Lots of people joined this, so very excited to see so many people, to be honest, interested in model governance. We hope you'll kind of come along to our next session. Thank you so much, Sam and Pete, for running this, and fantastic job. And please be in touch with us if you have any feedback, if you loved it, if you hated it. Every piece of feedback is a gift. We'd love to hear from you. And tell us how we can improve, and tell us how we can keep helping you and keep helping the industry as well. We want to bring the industry to be more positive, more focused, and really focused on building, and basically want to turn this into a fantastic initiative that really solidifies MMM's place in the marketer's toolkit. So please get in contact with anything along those lines. Thank you so much, everybody. It was fantastic to see so many people over lunch.
Awesome. Thanks very much.
Thanks, everyone. See ya.